Hello everyone. Today I am going to say about the topic of very basic of 8085 microprocessor basics. So I have divided the course. First you are giving, this is the introduction, what is microcomputer, what is microprocessor, then going into bit detail about this structure. This is the bus structure and basic architecture. So, okay, let's start. Now, what is microprocessor? So, every time you know that the microprocessor is nothing but the processor chip which are using in any computer or any other you whatever now you are using in your mobile phone. So there is the processor chip. Here we are the processor chip, specially giving the microprocessor name. So what is the function of this microprocessor? Micro means small, very small. So microprocessor is a programmable device. It is a programmable device, so it can process any kind of arithmetic operation, logical operation. So how it is doing the arithmetic operation? Taking the numbers and perform the arithmetic, or that is the according to your program any logical operation, and producing the result. And then the detail about particular, what does the mean of the 8085. That means 5 stands for, here the microprocessor operates at the voltage level 5 volt. Then 8 means it is a 8-bit processor. I will come it in later what is the meaning of 8-bit processor. And then 80 means 8085. So first 80 means that it is developed in the time of the 80s, particular in the year of 1976 that 8085 was developed and launched. So as it is in comes in the 80s group, so that's why it is the 8085. Bit interesting, na? Then what is the difference between microprocessor and microcomputer? So processor, not only that, when we are thinking about a computer, then what I mentioned there previously, that is microprocessor is taking the number. So from where we are giving the number? So if it is a computer, then it can make sense. Unnecessary, without this thing, everything is there present, not present there, so that processor cannot do everything alone. So microprocessor is the processor or the CPU in the of the computer. Now microprocessor is connected with the input device, output device, and memory. And the microprocessor, basically it is, as I said, it can perform arithmetic and logical operation. So microprocessor group, you can see the ALU, then the control unit, then how to control, how to perform the operation, and then the register array. Register array I will come later. Now here in microcomputer, what is the meaning of normal computer and microcomputer? Microcomputer means small. I mean that it is bit less inexpensive or less expensive. And in the CPU, I mean here the CPU, in case of microcomputer, in the CPU itself you can find the microprocessor chip as well as the memory chip. The memory chip is I mean memory chips, that is, you know, that ROM, RAM, that is read only memory, RAM, read write memory, these things are there. Along with this, the arithmetic and logical unit is there. Now then the bus structure. So as I have said that the microprocessor is getting the input output, sending, it is connected to memory everywhere. So when the how the information is coming to the microprocessor and how the information passing from the microprocessor. So in that way that we are connecting, that microprocessor is connected to the outside of the chip through the buses. Then what is the meaning of bus? Bus is nothing but the physical wire line, physical wires. That is the copper wire you can see, or in the PCB you can see the mounted, that the copper lines. So those are nothing but the buses. So the group of copper lines or physical lines is called buses. That is then group, that is group means when we are performing, we are making a group, that is we are, if the buses, that is the information and the lines are carrying the information for data, then we can say it is data buses. If the that is bus is connected, that wire lines connected to locating some other component location, then this is called address bus. Now, the other kind of bus is there, that is called control bus. Control bus means what? Microprocessor not only communicating with the devices, then I need to suppose you need to get the data from the input. So, your bus is carrying information from the input. So, that time that the printer is not connected, maybe the your input line is getting data from the keyboard. So, in that way, that is which bus or which device I want to communicate or microprocessor wants to communicate with at which time, then that should be processed through some control signal. So, microprocessor also generating the control signal, and the control signal is passing through these which lines, that is called control bus. So, there are three kind of buses you can see, that is address bus, data bus and control bus. Among them, address bus is 16-bit, so it can locate, that is 2 power 16. It is mentioned by location, it is mentioned by A0 to A15. Then data bus is 8-bit. Then data bus is bidirectional, that is it can from microprocessor to the devices and devices to the microprocessor, data can be transferred. Address bus is unidirectional, that is data from the that is the address location is sent out by the microprocessor only. Now, the important thing, that is the basic architecture. What are the blocks inside the microprocessor? Bus is the outside structure of the microprocessor, that is the line. But what is basically inside the microprocessor? So, we divide in, I mean, 2, 3 units of microprocessor, that is register unit, then then the control unit, like this. Now, first microprocessor, a bit description about the microprocessor. So, what 8085 microprocessor is a 40-pin IC package. This is the processor and this is a chip. So, and it that the number of pin in these chips are the 40 pin. So, it uses, just I previously mentioned also, it uses for 5 volt for operation. Then every digital system, they are running by some clock frequency or clock, any digital circuit. So its clock speed is, maximum clock speed is going 3 megahertz. Then it is having, as I mentioned, that 16 address line. So 16 address line can locate how many location? The 2 power 16, that is 64 KB memory location or input output. Then the control unit, just now I have said, that is control unit, that is microprocessor is the deciding factor, like our brain, it is deciding now I need to move my hand or now I need to move my leg. So that is everything decided by the our processor, our brain. Like this, also control unit also providing the timing and control signals, like control signals like whether I need to read, that is some information is coming, I need to read, whether I need to write, microprocessor, that is when you are storing some data, that is write. Then whether it is input output or whether it is communicating with the memory location, or whether the data required for ALU. So everything is required, sending that the as well as the synchronization, that is after what the processor will do according to some users program, as well as microprocessor also deciding. So that portion, deciding factor, is done by the unit, is called control unit. You can see here in this diagram, that is interrupt control is there, then other two control line there, serial IO control. Here you can see serial IO control. They are a serial transmission. Data can inside serially and outgoing serially. That is serial SID and SOD, serial input data, serial output data. Then here you can see X1, X2, these are two lines for the clock. One is for, the input clock and output clock, and the timing and control unit. You can see here another is clock out is there. That is the clock generated from the microprocessor. It can provide the clock to other devices. Then what are the other type of control signals with related? ALE, that is when the address operation is going on, then ALE signal, then S0, S1, IO bar. Just now I said whether the microprocessor is communicating with the IO device or whether it is communicating with the memory device. Then that is the IO and bar signal hold. Then hold signal. Hold means what? That is when some operation is going on, but you are prioritizing some other operation, then the current operation being hold, so that is sent by the hold operation. So these are part the control unit: timing and control, interrupt control, serial input output control. Then the other thing, that is the other ALU. You can see here ALU. In ALU part are the different parts. ALU, that is the arithmetic logical unit. That is, it is having a main processor register that is called accumulator. Then it comes with attached with the flags. Flags are kind of register. Then there are some temporary register. So ALU, what is the function of the ALU? That is, when you are sending some data to the ALU, maybe it can perform like arithmetic operation like addition, subtraction, this kind of operation. And one more thing, you keep it in mind, 8085, there is no direct command like multiplication and division. Through ALU, only through 8085 microprocessor only can perform two arithmetic operation, that is addition and subtraction, increment and decrement, and other logical operation like and, or, not, complement, like this type of logical operation also perform. Now, so the when the we are performing some arithmetical operation, so one data must be present in the accumulator, and after finishing the arithmetic or logical operation, the data result is stored also in the accumulator. And flags are the providing the status means what? If some carry is generated, then carry flag. If minus result is producing some minus negative result, then sign flag. So flags are nothing but the flip flops or registers. Then the another unit is register unit. You can see here we have mentioned B, C, D, E, H, L. So those are the registers. So register means what? It is the group of register is a group of flip flops. So, and the flip flop is the one, that when it is a making a group of either 8 or making a group of 16. So here in 8085 there are two types of registers, that is the general purpose register, which is accessible by the user, and the special purpose register. So general purpose register, you can see B, C, D, E, H, L. When any program is doing so, you can store temporarily some data, or microprocessor can keep some data, so that can be accessed by the user. You also, when you need to keep long data, also you can making a group of two register, like pair of register like BC, DE and HL. And the other special purpose register, as from the name you come to know that the special purpose registers are stack pointer. So when in a memory it is locating some memory portion, then the top of the, this is called a block of, if you are writing some program in memory, then the top address of the memory location is stored in the stack pointer register. So it is pointing to the top of the stack. Then program counter. Then program counter is another 16-bit register. What it will do? The program counter also keeping the track of the which, after which instruction we need to fetch. Okay, and then the increment decrement register, instruction register, then the instruction decoder, and the one more special purpose register, some temporary register that you will come to know in very detail then in the next classes. So for this we are concluding our lecture.